Hello, welcome to Tensar Ground Coffee, a few minutes on ground engineering to enjoy while having your coffee. Well, continuing with the Ask Andrew season, we've had a question just in from Sandy Gravel, and she asks, how do you design stabilizing geogrids? What a great question. What a specific question, let's say, but timely, as we shall see. Because that's what we've been doing just lately at Tensar, is thinking over recent years about how a stabilizing geogrid works and what features are there that can improve the mechanical stabilization even more. So this is the new Tensar Interacts geogrid. And as we've seen in previous episodes, mechanical stabilization works because these stones, they interlock with the geogrid. So with a bit of confinement from other stones above, that gets pushed into there, and now the stones can't move. If they can't move, if they can't rotate, you fundamentally improve the mechanical properties of the aggregate and you create a mechanically stabilized layer. So a stabilizing geogrid is a ground improvement technique, as opposed to a reinforcing geogrid like the biaxial geogrids that are designed purely in terms of tensile strength or stiffness. A stabilizing geogrid is very different. We have to think about what's the best way to restrict the movement of the particles and so improve the mechanical properties. So as I said, we've been thinking about how to do this, and then we come up with theories, we test out different ideas in our large tracks. You'll test in the laboratory also our trafficker test. And then when we've got a product that we think is got the best stabilizing properties, we then test it full scale for platform testing, unpaved roads, paved roads, rail and so on. And this is what we come up with, and it's got several features that significantly improve its mechanically stabilizing properties. So you'll notice that we've got different shaped apertures here, all different shapes that better match the shapes of typical aggregate. And you notice that we've got quite a large open area, particularly around here where there are no nodes. So we've got these oriented elements here with a lot of stiffness, but a lot of open space for the aggregate to pack together so we don't disrupt the compaction. That's very important. So we want to maintain the aggregate properties. And then you see the ribs are in lots of different directions. That maximizes the opportunity for stones to interact and interlock with the ribs in all different directions. So there's actually more interlock and interaction with the stones than there were in previous geogrids. You'll also notice, of course, the changing color. That's because there's a new material on the upper and lower surfaces that has higher frictional properties, so we get better friction and also slight indentation as well, so that also any particles that are in contact with the rib here, they're getting more confined due to slight indentation and better frictional properties. One of my favorite features is with these hexagons is if I lay it straight, because of these nodes that are thicker, actually the hexagon is standing slightly above the surface. So that makes it even easier for stones as they're placed to interlock and get underneath these hexagons, even when it's on a flat surface. So you see all those features go into making this a much improved stabilizing geogrid product. So I hope, Sandy, that's given you an overview of how we design a stabilizing geogrid. That's all for this episode of Tensar Ground Coffee. Thanks for watching and see you next time.